Tonight we want to look at the case of position versus time graphs. The lab that we're doing in class is creating these position versus time graphs, and I want to go through the basic shapes of all of our various position versus time graphs, make sure we understand the basic shape of each of these, and then at the end we'll do an example looking at a more complex position versus time graph and describing the motion that's taking place. When we think about position versus time graph, there's really going to be 7 cases that we need to know. Key points that stick out to us is 1, the slope of any position versus time graph is the velocity. If it's got a positive slope, it's moving in the positive direction. If it's got a negative slope, it's moving in a negative direction. The larger the slope, the faster the object's moving, the higher the velocity. The smaller the slope, the lower the velocity. If the slope stays constant, we know it's moving at a constant velocity. If the slope stays the same, if it's a straight line, then we know it's at a constant velocity. If it's curving, the slope is changing, therefore we know the velocity is changing. First case we want to look at is the graph where an object is not moving, it has 0 velocity. If it has 0 velocity, that means it's going to have 0 slope. And 0 slope is a flat line. The flat line will be at the position it's located relative to the origin. Here we're looking at a graph where we have that flat line. That flat shape is always going to tell us that it is a not moving. Now this actually, the picture I grabbed by mistake is a velocity versus time graph, but the same principle works if there's a position versus time graph. This would be not moving. For velocity versus time graph, this would be a constant velocity, but we are going to look at position versus time graphs. So here we have 200, if let's say this were 200 centimeters away from the wall, or whatever the origin point is, staying at a constant speed of 0, since it's a flat line, not moving at all. If we have a constant speed graph, here we have a position versus time, 2 different graphs, the red and the green, the red with the circles, the green with the triangles, both moving at a constant velocity. The red is a faster constant velocity. It covers 100 meters in 5 seconds. The green covers about 25 meters in that same 5 seconds. They're both straight lines, same constant slope. You could do a y equals mx plus b for these. And so they're moving at a constant speed away from our 0 point. Red faster, green slower. Here we have something moving the opposite direction, the negative direction. Here it's moving away from in the 0 direction. This would work just as well if you started at a positive value or moving back towards 0. The left-hand side is a slowly moving constant velocity. The right-hand side is a much faster moving constant velocity. Steeper slope on the right, so faster velocity. Smaller slope on the left, lower velocity. The remaining 4 cases that we're going to look at are curves. When we have a curve, anytime there's a curved motion, you know that the velocity is changing because the slope is changing. In this first case, you notice the slope is increasing. It starts with a relatively low slope covering about 5 meters in the first 2 seconds, then starts to increase in slope, and by the end it covers 145 meters in about 2 seconds, or 45 meters in about 2 seconds. So it's increasing speed, the slope is increasing, it's curved with an increasing slope, meaning it's speeding up as it moves away from our 0 point. The opposite of that is slowing down as it moves away from our 0 point. Here, large slope, it covers 45 meters in the first 2 seconds, and then you see it decreasing. By the last 2 seconds, it's only covering 5 meters in those 2 seconds. So it's slowing down. You see the slope decreasing almost to 0 at the end. Still moving away from the origin, but now the slope's decreasing, so it's slowing down. Now we're moving toward the origin, or in the negative direction, in this case in the negative direction, speeding up, the slope is getting larger. You see it sloping with a negative slope, which means it's moving in the negative direction, which either be back towards the origin or in the opposite direction past the origin. In the last case, you see the slope decreasing with a negative slope, moving back in the negative direction or towards the origin. In this case, it started at 0, so it's going away from the origin in the negative direction. Anytime you see this shape, we know it's got a negative slope, it's moving in the opposite direction, and it is slowing down.